Okay, now I understand there's a threat coming to GNSS accuracy or transmissions coming up in the form of solar activity. What is it and what might it do?
Yes, there is a threat. We're referring to this as solar cycle 25. Right? So every 11 years, our sun goes through a period where the poles of the sun flip. And that causes a whole lot of activity within the sun. And it makes the sun active, and it increases the number of sunspots and the number of CME events, or coronal mass ejections, right, where charged particles are leaving the sun and hurtling towards our planet and wreaking havoc on our atmosphere.
Are those also called solar flares?
Yeah, they can be. Yeah,
Okay.
Similar type events. So really what this means for us here on the ground is these charged particles and these increased solar emissions, wreak havoc on our atmosphere. And of course, GNSS signals have to travel through our atmosphere to get to us. And so when our atmosphere is disturbed, it also disturbs the carrier waves coming down from the satellites, or the signals from the satellites. And that ultimately results in lower precision on the ground, right, for our rover receivers that are tracking the satellites.
Okay, now how does that affect, go one step beyond the receivers? How does that affect the GPS positioning, machine control, things that our equipment managers and operators are dealing with on the ground?
Sure. Well, I think we're used to these very precise positions that we're getting from our receivers on the ground that are, controlling our machines or allowing us to do land surveying, right? And so we're used to these nice, like say 2 centimeter level accuracies that we're getting, and that allows us to do a very accurate job. And ultimately what happens is during these events, we have more cycle slips, we have more interference on the actual carrier waves that are coming down, causes a lack of correlation, which ultimately results in a harder time keeping those precise positions. So you go from that nice 2 centimeter level that we all like and we all need, and all of a sudden it begins to stretch out. You'll start to see a meter or half a meter of error in your measurements, right, if left uncorrected.
Okay, so now for operators and managers and companies, that's possible rework. That's time and money.
Yeah.
So what can be done to mitigate this?
So really, in a Trimble solution, if you've got a Trimble base and a Trimble rover, like so many of our customers do, they can take advantage of Trimble's IonoGuard technology, which works to mitigate the impact that these events have, so that we can send information from our base out to our rover, and we can weight the solution so that we can actually begin to decrease the impact that these atmospheric events have for that type of solution.
Now, how does that work?
Basically, what it's doing is there's a couple of things going on behind the scenes. So at your base, we're tracking. Hopefully you've set your base up in a nice open sky position and you're getting really good information. They can compare signal to signal. So for instance, an L1 signal to an L2 signal, right? Or an L1 signal to an L5 signal. And what they're looking for is the variance between those signals, because there should be a predicted amount of variance, and of course then there's the amount of variance that you're getting during one of these events. And so that information can then be put into your correction stream and sent out to the rover receiver that's maybe out on your machine, or maybe you're doing your grade checking, and it can weight the solution. So we've got algorithms that are inside the receiver firmware that can then weight the actual impact of a particular signal from a particular satellite and still give you precise position out there at the rover.
So this is in real time?
Yes, real time.
How do you get that? I mean, is that free of charge if you have Trimble equipment, or?
So IonoGuard was introduced last October, so October of 2023, and it was part of the 5.63 version of firmware. So anybody who has a firmware maintenance plan, or is of course buying new equipment with updated firmware on it, would have access to that firmware, and it was included as part of that free of charge.
Okay. What happened 11 years ago? I'm just curious.
A lot of the same, right? I think that if we think back to 11 years ago, we were really focusing on having multi-frequency receivers, right? And that allowed us to do what is referred to as ionospheric free, right? So iono-free type ranging to the satellites. And that allowed us to mitigate some of this, some of these events where we were able to mitigate some of the impact. But ultimately, it wasn't solving the problem to the extent, or mitigating the problem to the extent that IonoGuard does.
Okay. Is there anything else equipment managers can do to prepare?
I think the biggest thing, we have to kind of go back to basics in some of these situations. We used to do a lot of pre-planning before we went out and we started doing our GNSS missions, right, or our GPS missions. Always a good idea to keep track of this information, keep track of solar events, watch the NOAA website, watch spaceweather.com, look for announcements from Trimble that we're talking about it, and support bulletins. Keep an eye on GNSSplanning.com, which is a Trimble website that's showing what's going on with our ionosphere. Always good to be prepared. And if you can, avoid the worst of them, certainly, that's a great idea. Otherwise, make sure you're using a Trimble solution. So you've got a Trimble base and a Trimble rover with IonoGuard enabled to make sure that you're able to use IonoGuard to mitigate these, and make sure that you have other tools in your toolbox as well. So Trimble offers other correction products like Trimble VRS Now Networks or Trimble RTX, and both of those other technologies also have mitigation routines that can help mitigate the impact from these events.
Jason Evans, thank you.
Thank you.